So we just have a different form for the equation, a quadratic equation. It's called the vertex form because really everything's right here. You could even just look at it or pick it right off the top. There's a lot less plugging in to do. This is it. That's why this is a nice form to get the vertex. So you notice it's still the same a times x minus h quantity squared plus k. Well, h is the vertex, x coordinate of the vertex, k is the y coordinate. And the axis of symmetry is x equals, of course, the x coordinate h. So when we're looking at these, what do? So we got a couple, two main ways. We'll look at the ways most of us will probably be nice to think about. X minus 4, so quantity x minus 4 squared plus 1. Well, when we try to figure out what that is, we can think x minus 4 equals 0. What's x? And we did many of these right now. X equals 4. And we just use this value right here, the constant, the whatever, as your y coordinate. Done. Axis of symmetry, x equals 4. For b, same thing. What's inside the parentheses? X plus 3, set it equal to 0, x is negative 3. And then use the minus 5. Axis of symmetry, x equals negative 3. That's pretty straightforward. I think about it in that manner each time. Just, it's quicker that way even for me, and I'll tell you the other one in a bit. So, now what about graphing everything? Doesn't change, because we still need to get the vertex and axis of symmetry, but we get these in reverse order. We first get the vertex. How? What we just did above. It's what we did up here. We set x plus 1 equal to 0, so x is negative 1. There's the y coordinate. Done. So now we plug it, and then the axis of symmetry, x equals negative 1. So the vertex is at negative 1, 2. There's your vertex. Here's your axis of symmetry. Going right along there. I just included this to reminder if that a value is positive, which it is, 1, the problem is going to open up. It's a Kubitschek for you. So now, just like we did yesterday, we could pick 2 on each side. So negative 2, negative 3 is left or less. 0 and 1 is to the right or greater. And we plug it in. Plug each one of these 4 in value. So negative 2 plus 1, what value is that? Squared. So that's got negative 1 squared is a positive 1 plus 2. Plug in negative 3. Negative 3 plus 1 is negative 2 squared, positive 4 plus 2, 6. So this is where definitely put it in parentheses. But again, if you have a calculator with the whole big long line, type in exactly as you see it, hit enter, you're done. You could still hit that replay to change these x values. So still plugging in 0 plus 1, 1 squared, still 1 plus 2, 1 plus 1, 2 squared, so 4 plus 2, 6. And plot. So negative 2, 3, negative 3, 6, 1, 0, 3, 1, 6, smooth curve. That's it. So the only difference is getting this. Yeah, we're going to go through these other ones, so I'm not going to leave you hanging there. Okay, so again, vertex, x, what's inside, the parentheses, what's being squared, x plus 2. Make it equal to 0, so x is 2. The constant is 5. There's your y coordinate, axis of symmetry, x equals 2. Again, I included there, it's a negative 1 for a, so we know it's going to open down. So if it doesn't open down in our equations, we better double check our calculation. Again, 2 values on each side, so negative 2. So negative 3, negative 4, and negative 1, 0. Again, plug them in. Negative 3 plus 2 is negative 1 squared. That's a positive 1 times a negative 1 out here. So it's actually a negative 1 plus 5. Negative 4 plus 2 is Negative 2 squared is 4. So this is 4 times the negative 1. So we got negative 4 plus 5. And then we did the same thing here and get 4 and 1. Notice again, that symmetry stuff, negative. So we plot, I'll get back to the symmetry. So plot those points. Dun, dun. Here's negative 3, 4, negative 4, 1, negative 1, 4, 0, 1, and smooth curve. Sometimes it's nicer if you would try to draw a smooth curve, like start over here, go around that way, hit those points, and then start back over here and trace what you did over there, and then extend it that way. It doesn't have to be one smooth one. I find that sometimes nicer to do for me. But getting back to that symmetry idea, again, negative 3 and negative 1 are both one space from negative 2. They have the same y value. Negative 4 and 0 are both 2 spaces away from negative 2. They have the same 1. So that's what we did yesterday, the other part, and we're going to go ahead and show that in the next examples. Okay, so again, look it over. If you want to take that first, so positive 1/2 is the coefficient of the square, the a, so it's open up. Okay, so instead of thinking x minus 3 equals 0, so x equals 3, and x equals 1, the vertex form's also a transformation form. So what's the transformation for x minus 3? It's right 3. So transform from where? Where did we shift it? Well, we shifted it from 0, 0. The originally parabola starts at 0, 0. So we shifted right 3, the vertex, this is the right 3, up 1. Well, right 3 of 0, 3, up 1 is 1 from 0, 0. Ta-da! And again, the axis of symmetry is x equals 3. So we go ahead and do the same thing. This time, if we're going to use that symmetry, going to use one side only. And I just happen to pick on the left side here. So value is close to 3, but all on one side. So we just happen to pick the left side. So 2, 1. So plugged in 2. 2 minus 3 is negative 1 squared. It's 1 times 1/2, so 1 1/2. So that's 1/2 plus 1. Plug in 1 minus 3 squared. So that's negative 2 squared is 4 times 1/2 is 2 plus 1, 3. Now, when you put those in there, that may not be enough for you. If you don't think that's enough, go ahead and plug another one in. Now, why did I skip all the way to 1 or negative 1? Notice when I tried an x number or x value that was even, I got a fraction, I got a decimal. Here, odd number, got an integer, a nice number, so why don't I use another odd number? If you notice that or something like that with the ones you had, you may want to try that. And that's up here. So again, using the symmetry. So negative 1, positive 1 is one step to the left, so the same y value to the right, one step. Here 1, 3 is 2 steps from x equals 3 to the left. So if I go 1, 2 to the right, I got to stay at the same y value, and then curve. Same thing. What's a? So open down. So however you want to think about it. Again, transformation. Oh wait, that's a shift left 5 units. So 0, left 5. This is an up 10. Boom, done. Or do what we just did. Now we also did this in the transformation. Been a while, but so x plus 5. Okay. Again, same thing, no different. Nothing different as the other ones. Again, vertex form's nice, it picks it up. So again, if I use 2 on one side, let's use negative 4, 3. So let's use the ones greater than 5, negative 5. So negative 4 plus 5 squared. So that's negative 3 plus 10. 2 squared. So we got 4 times the negative 3. Negative 12 plus 10. So boom, boom. And then, so that's symmetry. I did the right side of the parabola. So the left side, so one step to the right was at this y value, so at the same y value, it's one step to the left. Here's that axis of symmetry, you could barely see in there. 2 steps to the right gets this y value, so if I go 2 steps, 2 units left, I get that same y value. Okay, notice how this gets pretty real steep, real narrow. That's because of that 3. Okay, so let's try to see what we got.